I use
Yeah.
PS4.
Yeah, it's fine.
This one is more designed for the.
This is more for bootstrapping, fast learning. We will see how it works in a few minutes.
Okay. So I will speak English because we have some international friends. So thank you for coming for the second lesson of Urbe Campus. Today we are going to deep dive inside the Solidity code, how to code a smart contract, also how it is a smart contract, what is a smart contract. So we have yesterday we had like a more introduction lessons. Today we are going to go like hands-on on the code. And just some information, we have some t-shirts for you, some stickers, and so after maybe in the course of the lessons you can grab that. So please, Drone, that is one of the most experienced Solidity dev in Urbe.it community. Please for the lessons.
Okay. Yep. I'm Drone. You can call me Claudio as well. And okay, I want to know just a few things about you. Anyone ever like took a look at Solidity or is like experience with similar language in general? First time, everyone. Is it the first time for everyone starting with Solidity? Okay, so okay, so we're starting very low from the basics. If you have any question or don't understand something from my English, talking for the Italian guys, you can talk me in Italian, and we are just fine, I guess. Okay, so I'm not fully aware of what the yesterday lesson. What was the overview until so I'm going to quickly maybe I will say redundant stuff, but just to make sure we are all on track. What is Solidity? Solidity is one of the languages that you can write contracts on Ethereum. It's not the only one, but is by far the most used. Like more than 90% of contracts are written in Solidity. So we better start from here. And what is a smart contract? Have you talked about what is a smart contract yesterday? I guess. If you have any like question about what is it or what they are for, you can ask now. I think Fabrizio made a good introduction yesterday. Is okay. So we generally have, just to recap, two entities mainly into Ethereum, which are externally owned contracts, accounts, and smart contracts. The first are the one you import in MetaMask. You interact with the blockchain using your externally owned account, and the smart contracts are basically the entities in which you run the code and they manage all the logic that we write in. So let's start very simple, and we may actually this is Remix, and you can navigate to it. You can just Google for Remix IDE or just go to the Remix Ethereum.org, and you will be asked some very like first time thing, like you can skip all the things. What we want to do is basically at first create a contract. We can like just create a new one in here, as like exactly like a Visual Studio or whatever. Contract. So okay. Okay.
We have also the links in the Telegram group.
Okay. Okay, but it's okay. Just look for Remix. All right, so let's start simple. This is a very, very simple contract. The first thing that sorry, do you all see? Can you see? Okay. First thing that we have into a contract, we will be always be asked to write a license. This is nothing very difficult, but there are generally many licenses that you can use in there. That's just for example, MIT. There are a couple SPDX license that we can write on top. Most of the contracts you will find to have this, and these are just needed for the compilation for the compiling of the contract. It's not really anything that you just can write every time. This one, it's very easy to find. Then we have pragma solidity. So basic pragma solidity is needed to declare what compiler version we have, because I don't know if you talked about it yesterday. Solidity is an evolving languages. Sometimes new features are kicking in, and so we have many versions that keep improving the language. And pragma solidity is basically a way to tell which compiler version is fine to work with this contract. And it's very, very easy. You can just do a range, but you can also have a way more simple approach, which is creating this way. Oops, I think not. Oops, sorry. Whatever. Yeah, I don't exactly remember why it isn't the 0.0. Okay, whatever. You can just write that way. It means any version after 0.8 is fine for compiling this version. We will see how compiling what compiling is just in a few minutes. So this is a very, very simple storage contract. As you may notice, we have just a number declared, and we have a function to write on this storage slot, so we can actually modify this number, and we have a function to read it. We will look better at how it's working in a minute, but this is a very simple contract, and when I'm done writing contract, I can just Control S to compile this contract. If it does have some syntax error, you would be the compiler will fail and tell you what is not going on, what is the error basically. So on the sidebar on Remix, it's really that simple. In with that button, we can see the green button means that compiling was just fine. And in this section, we can see that we have all the compiler version that we can work with. You are safe to work with the most recent one. So it doesn't really make a difference for now. The more you are getting experience, the more maybe you need to figure out compiler version. But for now, just pick up a recent one and we are fine. So we can compile in Remix. We can quickly compile a contract, and we have also this button just below to deploy this contract. So making this code will be compiled into bytecode, so that the Ethereum virtual machine is able to execute it, and we will be able to deploy. In here we can configure what will be the environment. For example, by default, Remix will run a virtual machine for us, so we can make some local work, which is faster than sending transaction. Otherwise, we have like different methods. If you do, you all have like the MetaMask extension. Okay, we will later on we will be using injected provider, which will figure out what extension we have. And so, for example, in here we click on that one, and should be connected with my actual account. So whenever we are interacting with the contract, we will do that on the network we are connected through our wallet, which is in this case the base Sepolia testnet. So this is mostly the tab that we will use to interact easily with the contract, and of course to deploy it on the net. So let's roll back just a little bit. We can start by defining what are the types we can use in Solidity. So what are the objects that we are going to use? So first, as you can see, we have all the code in this outer block, which is contract storage. And so we declare that inside here we have actually a contract, and we declare its name, so the identifier of the contract, basically. And we have a very simple one that, as I told you before, just lets you write a number and retrieve it. Let's just quickly delete this one, and let's talk about what are the types in Solidity. So of course we have uint 256, which is one of the most used, basically. Uint 256 is basically the larger integer you can use in Solidity. We are going to see that most of the integer values are up to a maximum of 32 bytes. So we have 256 for that reason. But in general, we can use different notation for the unsigned integer. By the way, unsigned integer uint stands for it doesn't have a sign, so it's just positive numbers. Okay, but we can also have like int 266 int number. That's work just as fine, of course. And for each one of these, we can have basically one type for many byte lengths. So we can have like uint 8. We can have like okay. AI is helping us. Solidity Remix introduced this feature recently. So we have for multiples of 8, we can have different byte lengths, basically. Nothing really that important. This comes more when you need to optimize the space you are utilizing from the storage. But just to let you know, there are many different notation for integer and unsigned integers. So whenever we are we are declaring a value like that number, we are actually declaring, we are actually stating that we have a storage slot which will be corresponding to that. So that it's very similar to other language variables. Very you are all confident with some programmation language, or okay. Okay, so we talked about unsigned integer and integer, but in Solidity we also have strings, and we may have bytes 32. Bytes 32. And what else? We can also have like literally bytes. Bytes, whatever. Okay. And so bytes 32, of course, is just mark up to 32 bytes. Bytes is like a concatenation of, it might be very, very long. So no limit on the usage of that. And these are pretty much all the types that we need to use to work with Solidity. I don't have necessarily more than that. This is like something that we are going to do a lot, declaring storage values. And of course, they come up with visibility. So you have any familiar with visibility from other languages like private variables or whatever? Okay. So we can make a very, very simple example in here. And at this moment, this variable is by default public because we are not declaring anything, but it's good practice for readability purpose to have a declared identifier for the visibility, from the scope the visibility. So, for example, if I type in public number, let's like say public number. Oops. That means that any of the contract that I mean, this contract can read this variable, but also external actors like other contracts, or you simply from outside the blockchain can just access this value and read it. We can also have like private or internal, which was a little bit different. Like if we write in uint, by the way, if I only write uint, is always going to default to the longest one. So this and this are pretty much the same. So for example, now I write internal number, and we can also have private internal private number. And the difference between these are basically, if now I compile this code, let me just go to the local virtual machine. If I quickly deploy this, you will see that basically the only number that I'm supposed to see is actually the public one. And so Remix will generate these buttons on the side whenever I'm deploying a contract, which is basically a program, by the way. It will create these buttons that will make very easy to interact with the chain at first. So if we click on that, of course, it's going to give us an empty value because we didn't do anything with that. We just declared the value and it defaults to 0. So from the outside, we are not going to be able to read this value for now, but internally, this contract may be able to read both internal and private. So the difference between these two is mainly like the scope on the contract side. So internal is something that just the contract is supposed to use. But other contracts that may be like contract that let's say that you inherit this contract into another contract. Internal will be still visible, while private means that only this contract will be able to read it, even if this contract is inherited by something else. We will talk later about inheritance, but it's very similar concept to all these languages. So let's talk about functions. Of course, when you declare a public value, as you can see, I didn't do any view function to read this one. Solidity will generate automatically a getter function, so you are be able to read that. But let's say now, let's just write a very simple function to write on those values. As you can see, like okay, it's just suggesting us to create some function in here. Let's see the function set into number int internal number. Why is not making suggestion now? Internal number is equal to internal number. Just to make a quick sample now, if we deploy, we should have these two functions now. This, of course, will set the number. Okay, we can click on it, and we should see that we set the number 1 to 1, of course. And we have this other function that we can use to set the internal number, basically. So we may also read this one if we want to. We can declare a function that get internal number. Int public view returns. Okay. Okay. So very simple. We cannot directly read this internal value externally, but the contract can expose this one. So if we set the internal number as 2, we can use a function that returns this internal value. So it's just up to you. Generally speaking, why there is this difference about public, internal, private, and to be honest, there is also uint external number. Sorry. This is mostly because these values are external. It doesn't like external. What the whatever. I'll talk to you about this later. So the difference is mostly for gas optimization. Like, do you make some talk about what is the gas in Solidity? Okay. So for now, as you are just learning, it's okay to use a public an internal, and you can just not care about like private or external. External means that basically external entities can read the value, but the contract itself cannot. And a very important things about this, because it may be misleading, private doesn't mean that the value isn't readable from the outside. Like, the contract may not be able to programmatically access this value, but from the outside, since Ethereum is a public ledger, we will be able to read this value. So don't fall for that. Private doesn't really mean that it's not readable in a more like general sense. So that is very important. Of course, this applies also to functions. So we may have function visibility. As you can see here, I declared public functions. That means everyone is able to call these functions. And we can make the same scope visibility for those functions. So if I'm writing like internal in here, we are not going to see this function anymore, but the contract may still use it. If that function is like wraps in some logic that doesn't need to be like called by someone else, but it's internal logic, the main benefit from it is like, of course, protecting the function to be called by random actors, but it's also about gas optimization. Like, internal function are generally cheaper than declaring stuff public and whatever. So let's delete those so we can more clearly see that. So we have different types also of functions. For example, that one is just a public function. It does affect storage of the contract, because we are actually overwriting the value in here. So we pass in a public number, and we set this public number to be changed. So we are changing state into the contract. But we have also function that doesn't necessarily make a change, which is a view function. For example, if we write get public number, we can just not have any argument from it. We can have internal view, and of course we are trying to have some return from this function. So we can when we are dealing with view functions, but we can declare the type we are expecting from it. Let's say this was a 256, of course, and we can just return this. Or we may have like a pure function. You may have the pure in other programming languages. Like, for example, we have it's basically something very similar to a view function that is just the most abstract possible. Like, for example, we can write a function that takes in like pure fun uint A and uint B, pure returns public returns uint, and we just make the sum of those. And this is these two are generally basically the same. Pure function is more abstract when you don't need to like read variables, but from the storage. They are cheaper, but they are not supposed to deal with storage. Like, for example, in here, we are just making the computation out of what we pass as argument into the function. And of course, all these functions, as I told you earlier, can be made private, internal, or in that case, external. And difference between public, and external is that public works both from contract side and from external side, while external is just from external readers. So if I have external function on contract A, contract B will be able to read it. And it's generally cheaper than public, basically. These are all concepts that the more you are in Solidity, the more you will need to learn, because gas optimization it's very crucial, especially in Ethereum on the Ethereum network, because it's not that cheap. So this is something that you will learn eventually more in the future, but for now I'm just telling you that this kind of things are the basics to Solidity. So we talk about these simple functions, and we may also now talk about data structures. So what are the data structure that you can leverage into Solidity? So basically, the most obvious one are arrays. So if we have, we can utilize the same type identifier we use for like single storage values, and we may add just the square brackets to make this be an array. So let's, for example, say that, let's, for example, say that we have a function at value to array. How do I disable this AI stuff? It's like, okay. Uint 256 A public, and let's make this function just add some number into this this array. We can simply type in pub number, which is our array, and it's really that easy. And pub number. Okay, so very similar to other languages, nothing special about it. We can deploy this contract. We can read that this actually is a length 0 array for now. If we add value 1, we are supposed to find 1 into array 0. And this is very straightforward if you have any knowledge about how the array works in programming language. Any question about how does it work? It's clear for you?
One question on debugging. How is debugging going in the Solidity? For example, with us push A, I think it is a string or it is other data types.
Okay. Yeah, sure.
Error here or after.
Yeah. So basically, you are going to be stopped earlier. For example, if I'm writing in here a different, so the function now does expect 256 uint. Of course, if I'm trying to run function to write for example, pass an int value in it, public pub number push A, the compiler is going to notice that something is wrong. So it's of course there was a typo, but yeah, member push don't find the back, because we are trying to push a different type. So Solidity is generally something that you can expect some error that will occur at runtime. So it's very important to figure out with a little bit of experience. You get used to error that are not shown when you are compiling. But generally speaking, if you make some mistake about the types and whatever, you won't be able to compile, and it's very easy to debug in that sense. So let's talk also about construction, which is very, very important. So you can think about like a contract more or less, not necessarily is the same thing, but more or less as a class in other languages. So of course we have a constructor construction phase during the code execution. So for example, if I now write in here constructor, this is Solidity will generate always this constructor if empty. So if you don't need a constructor, you don't have to like declare an empty one. Solidity will take care of it. But constructor is needed for initialization for the contracts. So let's say that we want to, let's go back in here. Okay, no, we'll use that to show arrays. Let's say that we want to initialize this simple array with some value already in it. So we don't have to push it from ourselves. Constructor takes arguments, so we may be able to write uint, for example, first number, and we can write some logic in here, like uint, pop number dot push first number. So very easy one. This will initialize the contract, and the first thing that it will do at runtime when deploying the contract will be to execute the code that we write in the construction phase. So if we quickly delete this, we can see that after we compile the contract, as you can see in here now is asking, there is a new field in here, like is asking us a value to put in. Without this value, we cannot deploy the contract. So if we write in 2, for example, as you can see, the deployment would go just as fine, and we will have on index 0 the value that we push in. Very straightforward, and that is so. Let's go a little bit. Let's roll back a little bit to. Yeah, sure.
Do we have null value here?
Null value.
We declare the variable, but it doesn't have the value.
No, not strictly like null, like you will have in JavaScript or whatever. You usually like check against like default values. For example, you have a string. If you want to figure out if a string is null, you read the length. If it's 0, the string is not initialized, basically. There is no like null. You just refer to the default values, which are like 0 for.
Here, for example, for top number, under my number, we didn't assign any values. So if we don't, it's not.
Yeah, exactly. If we initialize.
But after initialize, it has a value. It is not.
No, I mean, as long as you declare the value like that, yeah, it is not. This is an array of length 0, so no values in it. It's not really null. It's just an empty array. After we push the number in, it has length 1, basically. So we can find in index 0 that 2. No, it's okay. It's okay to ask.
Do we have something like unwrite wrapping the non-values, because sometimes we need to check if the value is not, and then go for the logic. If not, we just stop and do something.
Yeah, we don't.
Something like this in Solidity.
Not necessarily.
I think that we got to replace the logic that you handle with now with the float value. So instead to check if the string is null or not, we check at the level of the string.
Yeah, exactly. We refer to default values to figure out things. Okay, so now that we spoke about that, we have a very simple overview of what are the types, what are the visibility, and we haven't talked about like all the data structure. So array are a thing. You can have array of any type of uint. So this may be also like uint 64, for example, or maybe strings or bytes or whatever. This works for pretty much any type we have in Solidity. But we have something that is probably one of the most used things, that something that you will be able to use a lot, that is a mapping. So let's say that a mapping is basically any you have any like confidence of what are hash tables, like whatever, like the contract will look basically all the values in a mapping are actually initialized as default, which is 0 in the case of number, and you can write on it and it will stay on memory. Let's say let's see what it means. Like if we initialize uint, we can give it a name key. We can have like value, this one. So we can map a key to a value, very simple. And we can of course have the visibility in here. So this may be public or internal, depending on what are the necessity in your contract. And this is like simple mapping.
We can have also a key that maps another map.
Yep, I'll get there in just a few seconds. Like, of course, this means we can also like write that way, maybe something more like, okay. If we clear that very quickly, our structure. So we can like write a function to set the key, set key uint, set value, sorry, value uint key, uint val public. So the way we can actually use this simple mapping to write values on it is like we use its name, so mapping, and in the square brackets we use the key. So in that case, our key, and we can set val. Oh, sorry, that was a string. Okay, something that Solidity will do with generally strings and bytes, something that the compiler is going to tell you if you miss that, is that when you're using strings and bytes outside the storage, it will always ask for the value to be memory or cold data. These are like two this refers on where in the storage slot, in the storage of the contract, the value will be. In that case, when we are passing arguments to function, we are not using storage. So we have different kind of storage into the smart contract. The local storage, which is where we store the variables we wrote until now. And then we have memory, or in this case, cold data. And memory is general ephemeral memory. When you will run a function, you will have those values and after the function is executed, those values won't be, they just disappear. Difference between memory and cold data is very, there is not that much difference, but I suggest you use memory for now as beginners. Memory is more general use. You can have, you can initialize memory into a function. For example, like let's say now I want to declare a string into this function for whatever reason. There is no reason to, but let's say we want to do. String. Of course, this will throw an error, memory, even if we declare that way. And here we can declare memory that way, basically. We cannot do cold data, basically. I mean, we can, but we won't be able to use it because cold data is more like that part of the memory that comes from the code that we do from the outside of the contract. So when we are using MetaMask to send a transaction, the values that we pass in are in this location of the cold data, basically. And, when we send data to a contract, we refer to that as cold data. But that's just some more advanced stuff. You are fine to use memory everywhere. There is little to, it's something for optimization. It's good to know that this kind of stuff exists, but just be on memory. So to return to what we were talking about earlier, now we have this function. And as you can see, if I want to write, like, let's say on index 5 string hello, we can set this value. And of course, now this is a little bit different from array. So if you try to access something like in the array that we initialize, right now, this one has length 0. So there is no index that is readable. If you try to read an index that doesn't exist, like for example 5, it will give an error in here because the pointer tried to access something that doesn't exist. Mapping is a little bit different. It's like every value exists already. It's just not maybe written. So if we try to access 3, it will just give you an empty value. But since we use the 5, we can just retrieve this hello. Of course, this as the I don't know his name, but as suggested, we can have some more complex way to map things. So we can have a mapping, a nested mapping, so a mapping of a mapping. So we generally do that way. So we map a key. Then we write again mapping. We open the parentheses and say, let's say that we have another inner key mapped to string value. Okay. So as you can see, as soon as I try to compile, of course now he's expecting for us to use the mapping differently because we have another square brackets to write in nested mapping, like, for example. So it's really that simple. We can say that we have a key in here. So the first key and wint second key, for example, and we can pass second key in here and write a value. So that will look exactly the same, basically. But we can make more complex data structure for it. Yes?
Is like JSON.
Yeah, basically.
We have a key and value, and for the value we can have another key value or.
Not 100%, but like 90% that you can have up to 2. So you cannot make more. I'm not sure, but yeah, it's very rare to be honest. I would not do that. So into a mapping, you can also have like arrays. So we can have a mapping in which you map, for example, a unit to a uint to an array of strings or whatever. So you are free to use array into mappings. You of course generally don't want to use you cannot use like into the key into the key. The key is always like just a number, a string, or whatever. But you can have a value as an array. So we talked about the arrays, something about the mapping, and what else we do have? We have structs, which are very the same things of other things. Like you have your simple struct. You can declare okay, you cannot have an empty struct, but you can like of course, sorry guys, I forgot one of the most important one, type address, which is basically the type that correspond to addresses in Ethereum. So for example, this contract does have an address, and the address is just another type. So let's say that we have a simple struct of an address like owner of this contract, and we can have like age and a string name or whatever, something like that. And of course, we can have a public function struct. Of course, we can use this struct now into a mapping. Let's do that, like to make it clear. Like, let's say that. Oops, what the hell? Okay, like for example, key, and we can declare this. So when we create a struct, is Solidity now interprets simple struct as a available type. So we can like literally write in simple struct, because this type now is fixed for in this contract, and we can say like simple struct mapping structs public. So if now we try to access this this variable, of course it would be an empty object, because it's just the way we could initialize this is to create a function that writes the stuff into this struct. So if we have like function write struct, for example, we can pass in an address, yes, owner, int age, string name, public, and we can say no. Yeah, I always forgot about that, memory. So since we have now this type, we can declare it in functions. For example, if we write a simple struct memory, because this is like strings and bytes, it needs memory to be used. But we okay, we give a name to that struct, and we can say that this object is like simple struct. We can open up parentheses. I can't recall if that's the oops. And of course, now we need to to pass those variables that we need to pass in. So, for example, we have owner, and the owner is going to be, let's add an underscore. So, okay. So owner is equal to owner. Age is equal to age, and name is equal to name. Okay, so now we have this into memory, and so we created this object, we populated what we want to be inside, and if we just leave it like that, it doesn't it's not going to do anything. We want to write it into the mapped struct that we just created. So now that we have this simple object here, we can write mapped structs, for example, and we pass a key, let's say 1, for example, just to make this example, and we can say that at key 1 we will have this struct, so simple struct. And if we now redeploy this contract again, we have where is it? Like, let's say that I want to pass my address. I'm 20 years old. It's not true, but and okay, and I can just transact. If we go to key number 1, we can see that we wrote this object and we can retrieve it. Pretty simple. Any question about what we talked until now? Okay, very simple, straightforward. Okay, so we also have enum, which is like
Why we have liquid gas near the right side?
Oh yeah, that's something stupid about Remix, basically. For for some reason, like they are trying to estimate the gas expense of a function, and most of the time Remix will just like randomly to tell you that it's infinite gas. Generally speaking, infinite gas means like the function will revert because there is something wrong in it.
Okay.
But you just don't care because, right, it's just a visual bug of Remix. I mean, I can repeat that Remix is very good to make prototypes, like to bootstrap at first, because you have all these buttons and it's very it's more intuitive to figure out. You can play with it. The industry standard doesn't really professional or whatever don't use Remix that much, so you don't start with that, but don't settle that on the long term. Tomorrow we will see Foundry, which is a framework that you use to write Solidity smart contract, and you also use that framework to test this contract programmatically. So you write Solidity
End-to-end test.
Huh?
End-to-end test.
Yep. So you write Solidity, you write the test directly on Solidity. So you can learn Solidity while writing test. It's very. We will look at it tomorrow. By the way, one question about that. Anyone running Windows? No Windows. Fine. Okay. So we don't have to install anything strange. I will give you some link to install Foundry later when later at the end of the lesson. We don't really need Foundry right now. Okay, so let's talk. We have a little bit more or less all the building blocks that we can use in Solidity. Of course, when there are a couple things that we didn't talk about, which are like not that obvious, but we will find later, like for example, for cycles, if else, any instruction that you can pass in Solidity to like have conditional logic and whatever. It's very similar to other languages, so I don't think that we will have any hard time learning that. And for the first thing that we may want to do, let's try to like build something, for example, later. So I will give you some building block to do so. Any one of you already had like some experience like using the blockchain as for now, like using tokens or whatever? Are you okay? You did. Okay. So most of the time, when approaching Ethereum, we will hear a lot about tokens. These are generally like contracts that are used to have something very similar to digital money. So a token is like something that you can actually use as a representation of a currency, basically, or so we call that token in the blockchain. So what you can do with token is of course transacting, because as probably Fabrizio told you yesterday, the blockchain is very powerful because we can use this contract to automate some interaction between users. Like for example, if you are using for example, a payment app like Revolut or whatever banking system that you are using, there is no way to like interact without like the middleman. You generally trust someone else to like take the money from you and to someone else. There is no way to do that directly. You need an intermediary, and smart contracts are really good for intermediating between parties because they are actually trustless. So in the sense that if you want to send money with an application like Revolut or I don't know, any banking system, you actually trust that the intermediary is handling the transaction on his own, and that is mostly what Solidity can the smart contract can do. So one of the main use cases of Ethereum, as for now, but it will be for a long time, that are payments or just store of value, trading values between people. And to do so, there are these called tokens, and we have many different types of tokens. We will just look for the most used for now, and I think that if you go into Remix and want to play later on with that, now we will look at it very quickly. But I think you can just like create like a template, scroll on, and you can find these tokens. These are namely RC20, RC721, 155, but for now we just focus on ERC20, which is like the most used by far. And it is basically something that you can just play with it very easily. Let's delete this contract in here, right? And go into that contract. We can just compile that. As for now, you will see just this very simple contract. The logic is all behind this contract here that we inherit, which is a little bit more complicated at first, but it's really simple once you get used to how it works. It's basically a register of value. So let's let me just quickly. Sorry. Okay, I think that was the one. We can delete this. No. Okay. Okay. So if we go and delete this one, let me just write a function to mint. Okay. Just to make it clear, we can deploy this contract for now, and we will get later to get what I just did. In this particular moment, I used this function to create funds. You are not supposed to do that. It's just for demonstration. Like I minted some token to myself. In this case, I'm using this identifier, which is message sender. Message sender is something that you want to read to write when you create you have a function and you need to know, for example, in this case, who is the address that is going to receive the money. We can write message sender basically means who is the sender of the message when we arrive to this function. So for example, now I called myself this function, and for that function, the message sender, it's me. And we are like minting means creating. We are creating this amount, which is like 1 and 18 zeros to myself, basically. So I'm printing out of money out of nowhere. I'm like United States. So now we can see that the total supply is a lot because we have some. And if I go in here, in this account tab, we can see that we have a list of address that we can use to impersonate and play with it. We can just copy this address, and we can go into balance of function, which returns the balance that we actually have. And of course, it will correctly display what we have, and we can use, for example, let me get another address. We can use, for example, the function transfer. These are very standard, these are called standards. So you can expect this basic function in every ERC20 token. So they are easily, you can operate with it very easily across different protocols, different program. There are standard way to use those tokens. So for example, in here, I'm sending this guy like some value. I just can transact. And now if I refresh the balance, I will see that it will be updated. Very, very straightforward. And we have also something that now I made myself a direct transfer. So here in ERC20, you can have a transfer of value that you send to someone else. But most importantly, you can give the approval to someone else to use your funds. So, for example, let's say that I want to approve this other address that I took from the list in here to spend up to 1,000, for example. I just gave him like the approval to do so, and now, for example, if I impersonate this person, he will be able to call transfer from the address that I was using previously to another address. It might be like this contract or whoever. And we may be able to just send what we are approved for. If we try to transfer more, the token will be just, the function will be just reverted. But if we are spending less than what we have as approved or equally, we can just transfer this money on behalf of someone else. This is especially important when dealing with tokens, because you can not only, you don't want always to like send money directly to someone else, but you can make approvals to other people to manage your money when some condition is accomplished. Like, for example, most of the time you are going to do approvals not to other person, but to smart contracts. So that smart contracts may be able to move your funds with your approval, of course, on your behalf, and automate many interaction. Like in the blockchain field with tokens, you don't always just send money to people like you are supposed to do with a payment application or your banking system, but you can interact with a lot of other application. For example, you may have lending protocols. You may have like trading applications. You may be like using exactly, trading application in the sense that you can like swap tokens, or you can like gamble doing like scalping trading and whatever. There are so many kind of application, and most of the time this contract will interact with your funds, always with your consent, of course, and so this is a very important mechanic to use for. So we know that more or less we have this contract in here, which we just deployed. Let's say that now, for example, we can have this token, and we can describe what is it. So this contract, if I deploy this contract now, you can see it will have my token, which is the name of the token, at, and there is an address. This is the address of the contract. Basically, it is an address. So at this address only, there will always be this particular contract. So let's say that this is the contract representing euros, for example, and everyone is going to point at that particular address to interact with it. But I mean, also a smart contract can actually use this particular contract. So if we now in Remix you can pin the contracts. So if the application like crashes or whatever, you close the window, you can find what you just deployed in here. So let's make, for example, a very quick contract, so we can. What was the contract that we are doing earlier? Okay, let's make it It was that one. Okay. So let's talk a little bit about how we can use other contracts in our contract. In that case, if we go into here, you see we haven't spoke about it, but we have a way to import these contracts, and we will look at better managing of contracts and imports tomorrow with Foundry, which is more complex, but what's the contract I was using? Okay, so in this industry there are many actors that do open source code that is reusable, and one of these actors is Open Zeppelin, which has a very long list of created open sourced contracts that you can safely use because they are audited by the best professionals. So the industry often use Open Zeppelin standards, for example, for token, but for many other contracts that you may need to use in the future. For example, in here, we can just import the ERC20 token from Open Zeppelin. Just means that it is their own interpretation of the how it's supposed to be written, the logic inside it, and we write a at Chiocciola Open Zeppelin just to point that the actual is referencing GitHub basically. So if we go into GitHub Open Zeppelin, we can find the contracts repository in here somewhere. Yep, that one. And in here you can just navigate and figure out that they are doing a lot of things. But for now, we just focus on this one. So let's say that we want to interact with the contract that we previously used, and a way to do that is not to import the whole ERC20 token, but we can import the interface. So it is the interface is a smart contract that doesn't have any logic in it. It's just function signatures. So identify for these functions. For example, if I now click on that, I just imported the interface, and Remix is going to install node modules, and you can just find in it that way. But as you can see, it doesn't contain any logic at all. It's just the names of the function. So we use that because if we want to interact with an external contract from contract A, we want to interact with contract B. Contract A doesn't know what B is for. It doesn't know what function it has. There is no visibility in that sense. So we use the interface in the contract A. So we tell the contract A, hey, look, this contract here has this list of functions. They expect this kind of values to be the arguments, and you can expect this return and whatever. It's just like to operate through contracts. So if we go back in here, we can, for example, write a function to rather than creating a function, we can declare an object like ERC20 token, because this interface, is called the ERC20 token. So exactly like structs, we can, when we have a contract, we have an available type to describe this contract. So in that case, we can declare ERC20 interface public first token, I guess. And we can constructor address, token address, and we can just set first token to be equal to token address. Sorry, forgot about this. ERC20. So we open the parentheses to add the token address. So we're creating. We are saying this interface is used for the contract that has this interface address, and now we paste the address of the contract that we previously created. So now we have access to the other contract from within this contract, and we can make transfer from this contract. For example, if I now write a function deposit, and we write event amount public, and we can access to the function that we previously spoke. So now I already initialized this interface, so we can say first token, and as you can see, we will have the list of all the public functions that we can access from here. And for example, we can call from message sender, which means that where I'm going to call this, it will transfer from me to address parentheses this, which means this contract basically, and the amount, of course. Quick note: when we use message sender, it is not the sender that launched the transaction at first. It is the last contract, the last entity that called this function. So if we have, for example, I call contract A, and contract A calls this function, the message sender will be contract A, not me. Clear? Okay. So it's always the entity who is calling this function. To make it, let's make a quick test. We can compile this contract, and we previously deployed the token address. This is the token address, so we can deploy the contract in here. And now, if we transfer 1,000, it will revert. It does revert because we haven't gave any allowance to spend the money to the contract. So your money are safe until you mistakenly give authorization to a malicious contract. No one is able to steal your money, because the code is very strict. To do that way, we will have to usually application, when want to call this transfer from, will always prompt you to approve the funds on the token that you want to receive first. So let's say, for example, I want to deposit into depositing for a loan or lending protocol in general, like to make some deposit into a protocol. It will ask me to approve, and of course the spender will be the contract in that case, and we give the allowance to spend up to 1,000. Now the approval will be what the hell? Isn't the right one? Okay. It doesn't like it. That's for version. Sorry, yeah. Oh, maybe I didn't have. Okay. Because I deleted the contract, I wasn't having balance. I forgot to mint. Okay, so everything went well, and now the contract is holding this money. Of course, we don't have a function to get it back, so this money are lost now. But yeah, of course, are like virtual money. Okay, so these are mostly the function that you are going to call more often, because as I told you, like we have different protocol, like for example Aave. Anyone of you knows what Aave is? Okay, he knows Aave. Aave is a lending protocol. It's like banks, more or less. A little bit better maybe, because it's permissionless. You don't have to make a lot of stuff, and this is a very, very used protocol. Like there are a lot of millions into it, and you can just deposit some stuff as collateral in there, and you can earn interest because you are like lending money to other people. And so every time you want to, like for example, deposit USDC, because you find out that the interest is very good, you will be asked to approve. You will take your funds, and so that's one of the most frequent interaction. So, of course, there are few different types of token. For now, we will just work with RC20, but there are also NFTs. And any clue of what NFTs are? Okay, the other guys, more or less, let's say that they are differently from ARC token, that you can like more think about it money, like fungible money, like euros, dollars, or whatever. Tokens, like there is no difference from one token and another. They all equal the same value. NFTs are more like a representative token of something. It may be like the digital representation of a card in a trading card game, or like a credential, something more like a literal token, and it's mainly used by degenerate people in the field that spend money to have this stuff, but it can also be used in a good way, like for credential, for example, access to gated contents or whatever. So attestations, exactly. Like they are like tokens that have metadata in it, so you can write attach to them many information. They are generally different, but maybe we can tomorrow we can play with that. It's a very similar concept to a ERC20 token. The functions are pretty much the same. So let's go very quickly and look. I always lose it. Okay, that one. Let's go very quickly into looking how this contract is done, so we can introduce like how inheritance is working for this contract in particular. So as you can see in here, like we have this example declares my token is ERC20. This does mean that since we imported that contract, saying that my contract is ERC token, it means we inherit all the logic that is written into this contract on a lower level. So if this contract has public functions, as you can see in here, these are the functions that, if we go back into the token we deployed in here, we can find this function already working. We don't have to like rewrite the whole thing. We just import the token and notice that it is ERC20, and we inherit all the logic that is behind. Of course, we can make some different. We can make different things. For example, we can override this function to have different logic. So not all the contracts are of ERC20 are the same. Many contracts may have different features. But generally speaking, when we refer to them as standard, we are not referring to the implementation, so the actual code that is written in here, but we are referring to its interface. So an ERC20 token compliant contract inherits these main functions, and the implementation may be different. Just this. So if we import this contract, as you can see, as a constructor that is needed to work in this logic, and if we go in the outer contract that imports this token, you can see that we have a constructor in here that also initialize the constructor of the ERC20 token that we are using below. So we pass the name of the token and its symbol as he asked in here. So every token generally has a symbol and the name, basically. Of course, the main identifier is the address of the token. That's the most important thing. And so we simply have this. We can simply import this way. Of course, from here we can use functions that are not available in here. Like I wrote mint function, but mint function doesn't exist in this contract below. It's not a function that you see exposed, but internally. The ERC20's token standard has an implementation to this underscore mint functions, which is the internal one, basically. So it's up to us to declare how minting token does work in our contract. We may be writing our own logic, as I did in here. Like, you're not supposed to mint to the message sender like that, but I can do that because the rules of the inheritance. And Of course, you can override the functions that are already in here, basically. Yeah, for example, let's take one and see what overriding means. And you are familiar with the overriding in other language, no? Okay. You just declare a function, like for example, this function for this is virtual. This means that since this is virtual, so we can we can just copy paste in here, and we can just declare this as override. It means that now if we let's say don't bother, it's just like to show that this functions was supposed to do something and return true if if the transfer was successful. I just override to make it return always false. There is no reason to, but what we will notice now, will be the actual implementation of the function when we call this contract. If we deploy again, we can see that there is just one transfer. There are not two transfer. We override it. So that's pretty much it. And so you can have like different implementation. Generally with the ERC20 token, you're not going to have a very complex logic. They are very simple to use. Like if you need to, every one of you is going to do the hackathon in the next week. Okay, so it's very that simple. Like you will use maybe I'm not sure about the sponsor yet. I need to look at them. Maybe we can do something that is functional for the hackathon tomorrow. But yeah, that's something that very straightforward. If you want to play maybe with NFTs, you will have like to write some more complicated logic to make them work, maybe to attach different metadata to the tokens or whatever. So how much time is it? You want to make some like 5 minutes pause? It's okay? Okay. Okay. Not sure if I need to turn it off. Let's go. Whatever.
In compenso già questo.
Potete prendere maglietta, dipende che esce. Però a me è rimasto una roba. Allora due. Iniziamo, we can start after 20 minutes and we will have a session about how to get a job and how to get grants instead of Web3. Okay. Se mi serve qualche taglio, vi porto domani. Sì, sì, intanto se pensate che qualcuno di queste va bene. Ok, perfetto. Allora facciamo il suo programma. Molto bene, la lezione? Sì, come voi.
No, provavo sempre a servire.
Giusto. Va benissimo.
You presented something in ETH.
No, I was just attending.
Okay.
Just, no, actually, I'm the one event organizer. So that's for
Okay.
and but all the politicians are essentially. And so
They have?
yeah, they actually they won the first prize in the US as the most interesting.
That's cool.
Yeah, and also the third prize in months. Yeah, so
With those papers?
it was not. I think it was Gospel, the name of the project. No, I don't think it was Gospel. It was another name, but he had to ask to Bravo because he had.
Because they were, well, Caspero was our direct competitor. We built a payroll with CT groups, Tornado Cash technology.
About money max.
Yes. But it is okay. Like,
Of course, it's okay.
it's dumb, you know?
Yeah, it's a nice combination.
Yeah.
Yeah, but actually, you have to ask to Bravo because he was like the one that that's a process.
Do you already know which the sponsors are for the hackathon and the track?
In Napul?
Yes.
Yeah, it's if you attend 3 or 5 lessons here, you can also have some more bounties for the ETH because we offer 1K bounties for the campus participants.
Okay.
On top of that, there are 2.5K always from the ETH, so you can also
For using the scaffolding, right?
Okay. So, yeah. You can do that. There is the tag. I only if you did the registration.
Yes, I sent my registration.
Okay, perfect. There is an option with all the bounties. And there should be 1K from Avalanche.
Okay.
Some credits from Chainlink. 2.5K from DGA blockchain with our clients. That I don't think is technical, but it's like if you build a project that is sustainability, you get rewarded. That's it. So you have to also you have to ask to qualify. You will be one of the judges.
Okay. So
It's around 10K.
yeah, it's okay. I mean, like it wasn't planted. It wasn't in my plans. Like I came here because I'm visiting a friend. But I told him, I'd like to stay like 3 nights. That nice one. And then I remembered that there's a hackathon in Napul.
But it will be next week.
Yes.
Oh,
But so I'm staying 12 nights here.
Okay, that's perfect. Now makes sense.
So now I have time to get fun. Like the city, I have the cows. I remember.
Where are you from?
Mexico.
Okay, so. Yeah, we had like 2 people from Mexico City 3 weeks ago in Rome for a program, for a mixed education program. And so, yeah, you're from Mexico City? Or?
No, Campu.
Campu.
Yes.
It's nearby the sea or?
Yes,
Okay,
it's the beach place.
This place, yeah.
Yeah, all the people know Los Cabos, Acapulco, or Cancun.
Nice.
Yeah.
Cool. So you're spending all the summer, well, not all the summer, but part of the summer here in Europe.
Yes, I arrived at the 18th June.
Yeah.
But there's my family coming to Madrid like in July, so I'm going to spend another almost a month. Yeah.
What was your project in Campu? Not those big one.
Substream.
Okay.
We made you see Inmax from the sponsor.
Yeah, I know Inmax and Sopra.
And no, Substream doesn't have to do with Sapphire.
Okay.
We just set them to a similar name.
Okay.
So basically, the fact is that unlike other stuff, in Inmax, you don't receive your money to your 0x address, so the normal address.
Yes, we applied for the same company.
And we made it so with EMS, you just create a special subdomain that doesn't have as the address that resolves to your 0x address, but it's the address that is owned by Oasis the.
Okay, so you did. Okay.
So you give this to someone else. In the text record, it stores the public address of Inmax, and internally, when you give to someone else this address, he sends the address to it. And what he does is that he figures out that the money has been received, so he uses his internal Inmax address to send the money to the address stored in the text record of the MS, and he uses the money that arrived to the server's address to deposit back to its position. So we always have an liquidity to black end of this thing. So you don't have to ask people like, hey, I want money in Inmax, or deposit by yourself once you receive this domain, you just drop the name and the chat to someone else. This is very, very simple one, not that much code, but we started coding like 4 p.m. on the second day.
Same.
Because like we were.
And Inmax was down so much
Yeah.
time.
Yeah.
They
The last domain last weekend they were already down.
6 hours for a deposit was. But anyway, we had many ideas, and we thought like to find what we want to do at the end of the day. At the end of the day, we were like, we gotta choose something very simple and efficient because we don't have manpower. We were just two. So.
Same. Well, I did the whole go. And my friend wants to. It's really good. But I told him, let me try it by myself, and because I don't know how to deploy it. And to be honest, it's like it was my first time playing it. I learned how to do that. But he did. He removed stuff.
Guarda,
Yes,
non è posto, è molto
I think that it is online. If you want me to show you.
Yeah, sure. People is having a coffee or not.
I was start with inizio dovevo fare una piccola presentazione, faccio un quarto d'ora per fare l'ultimo ora intero. O no?
Vabbè, io volevo spiegare un attimo la differenza tra RC, perché ho spiegato gli RC20 e alternativo.
No, facciamo così.
La stessa cosa e poi
No, assolutamente facciamo così. Se mi finisci alle 10, cioè se un'ora va bene? Cioè un'altra Sì, certo. Però facciamo che finisce alle 5 e un quarto e l'ultimo quarto d'ora 20 lo faccio io.
Ok.
No, lo faccio io.
Ah, ecco, vediamo un attimo, devo fare un po' di codice. No.
Vabbè. Allora vai, tranquillo.
Non volevi parlare. Vabbè, allora sì, dai, ci sta. Dai, se poi facciamola subito, almeno. Facciamola subito, dai.
Hai dato pure USB-C HDMI? Hai dato pure USB-C?
Sì. Oh wow, I forgot the most obvious type in Solidity, pool, just Boolean. Okay, I think tomorrow we are going to build a simple application that is, I think we will do like a crowdfunding application, so we can make use of pretty much all the basic concept that we will discuss today and tomorrow, like using the tokens, managing mappings and whatever. And then with Mattia, who is the guy that will teach the TypeScript part of this course, you will build an application on top of it, so you can also learn how to call functions from an application in Next.js, I guess.
With the Solidity or other.
What?
With the Solidity, we can only use JavaScript.
So generally, most of the industry products are meant to be used in TypeScript mainly. JavaScript is just as fine. It's a little bit harder to find good libraries for languages such as, like, let's say, Python. I've seen people trying to work with some Flask application in Python, but there is less support for this language. It's not that it doesn't exist, but there are even things for Java, for example. But I'm not sure because I mainly use the TypeScript one, but they have less support, so it's really like it's better to learn a little bit of TypeScript. And
Before I tried to Swift for the iOS app.
yeah. Yep, I'm not sure about what's the current state of Swift.
If you feel comfortable with JavaScript, well, TypeScript is just a type
Yeah.
JS. And if you have most of your code on JS, you use wrappers.
Yeah, exactly.
And there are so many libraries. And me, as a non-developer, you just vibe coded it. That's it. Like
Yeah.
Rails.
Yeah, as a developer, if you don't make use of it, I strongly suggest writing by yourself is the best way to learn, of course, but vibe coding is getting more and more efficient. So you may want to use, if you are using VS Code, you can use Copilot, or you can use Cursor, which is an idea very similar to Visual Code. For example, let's see there. My PC is it's a little bit slow at booting from subsystem, but
I think you need to switch to Mac.
No. I don't like Mac. I should be just doing the partition, Linux partition, but I'm too lazy and whatever. And it's just a normal VS Code fork basically, and you have the whole thing in here. You can, for example, reference files. For example, like you can like tell, hey, look at that code and figure out what it does. For example, it gives you the EAS concept, context of all the folder. And as a beginner, this may be very useful because maybe you know what you want to do, at least, but maybe you are failing to figure out the correct syntax, or and this is very, very useful to bootstrap you on that, because it also has like the autocomplete. He understands what you are going to write based on the context of the folder. It's very useful. Just don't abuse it, because otherwise, like, you are just vibe coding and not learning. But it, especially in the hackathon,
You have to learn and the concept and then use the AI.
Yep. That's most important.
Reading documentation is the key.
Yeah.
Real.
Yeah. Exactly.
I'm a financial and fiscal engineer, and I mean, I can show on the screen what I've done.
Mm-hmm.
And if you permit it, it
Oh.
is not like for real.
Like,
It
I don't know
just,
if, because I think
it's type C.
we are doing the same.
Oh, okay, yeah.
I can just But yeah,
It is online.
if you need some assistance during the hackathon, I will be mentoring, so you can ask. But if I'm not there for any reason, give it a try.
The thing is that I have very good with the Swift, but if I can find a way to interact with the Swift,
There are libraries, but
yeah, I found some.
at the end,
I never like tried to.
at the end, when you will be trying to connect to a library that there is no super with Swift, there's when you're going to be stuck. That is the problem.
Yeah.
Like, I have a friend that installed MetaMask using PHP.
Yeah.
It is possible, but
Yes,
there are many
it's
features
possible.
that
In
are
theory,
not.
it's is a lot of work.
Yeah, because you will be depending on API endpoints
Yeah.
at any point. So it's just more code and more work. So it's keep it
But
simple.
this is
So you
like,
have to- it's just it has no funds, okay? It's a ledger. Yeah, it's a ledger. It has no funds, but
You need to see.
yes, because it's a ledger.
I know.
SDK.
Support, because you can
Like I can use.
the most used
It doesn't matter which they are.
are very
I don't even know them. I win it in Wallet. So it will ask for the device, okay? It is not triggering any of the wallets because it has a DVK, which is the SDK for interacting directly with your wallet instead of opening a Chrome extension. So now I should sign on this.
Yeah, I need to see.
So I try to understand how to handle them in the React Native just.
So now I can access.
Why don't you use this Windows?
I do all the mental stuff. That's what I like. So I have like very long and shift
less support. Java,
and then you can distribute the payment using Bitmax blockchain. Another cash mixing.
Okay.
Yeah.
Okay, so to hide the track.
Well, you know, the thing that I explained in the hackathon is that companies are targeted to be hacked. So if the hacker knows the company wallet, they will be targeted.
We can talk tomorrow,
Yeah.
like we will work with the
Employees, they have the right to
I started to follow the
be private.
Okay.
Yeah,
But at the end, they will
can
just cash out
the
the pay of taxes.
you have.
Oh,
Yeah.
want some bounty with Link Max? No.
No, I didn't get anything like
Yeah.
It's okay. I think that this time in Go, they choose
I made like very.
Windows also.
Yeah, I like it.
98. Yeah. Linux forever, bro. Yes.
You are solo or?
As I told you, yes, this is. I used to hack solo, like very little times I hack.
Yeah, that makes sense. You learn a lot, like by doing a solo. Okay. Yeah.
The only thing you don't learn is to work.
Yeah. Okay, so do we miss someone in here? Like, ma arrivano? Vorrei iniziare. Ah, ok.
Ti ho mandato, se vuoi faccio ora,
Vai.
ti ho mandato un po' di link su Telegram, se mi avere un po' di schede. Così ti scorro velocemente.
Qua?
Sì, tutto interessante.
Tutta sta roba, oh. Adesso sei impazzito.
Sono sì.
Ok, vai, fai pure.
Okay, so first of all, I'm Crypto Gallo, also known as Marco, because in Web3 we have different names. And so I'm not a developer, and I'm most of an event organizer. So I organize all the events for Urbe.it community, and my role is also to get funding for the Urbe.it community and understand how the people get funds in this ecosystem. So what I want to do now is like to give you a very quick workshop on how to get a job, how to get funding, how to get a grant inside the Web3 ecosystem. Because actually there are a lot of possibility also for like I think Italian builders, because the average salary in crypto space is like 6 figures or more. And it's way better than like a normal job in maybe it's not so stable, maybe it's not like normal, but it's way better for like a normal job in Italy or in other companies. So the first way to kickstart is with the Urbe campus, but you're already here, so you know about that. And the second part that you should do is to have an hackathon. So we strongly recommend to go inside an hackathon like what you're doing in Napul. We are hosting also an hackathon in October, from the 17th to the 19th of October in Rome. It will be, it's the third year that we do this hackathon, so it will be with a lot of international sponsors and attendees, and we have a lot of we have like 120, 130 hackers every year, and between 50 and 16K of bounties. But of course, if you want to level up, also if you want to travel more, there are ETH Global hackathons. ETH Global hackathons, like ETH Global, they are the main hackathons organizer. They organize like very incredible events with a lot of hackers, like more than 500 each time. and with more than 150k, also 250k of bounties. So it's very, very interesting. Like the next one will be in no, this is a co-working. The next one will be in New York. So here you can see on their page all the info about the hackathon. You can see that they have 250k of bounties on prizes. They have like industry leaders sponsoring that the hackathons. So it's a very good way to go there, try to develop something, try to develop an app, also to network with the best protocols, and to also win some money if you're lucky or if you're good. After that, I think that the easier way to get funding is also to continue your project. Maybe you have done a good project in a global hackathon or a normal hackathon. Maybe you have developed on a certain technology. Let's say maybe you have developed on layer 0 flow. Something went wrong. But yeah, if you develop on some technology, you can also ask for grants to that. Like, let's see if there is the flow. Sorry, I use Mac. On Flow AVM, let's see. I'm doing randomly, but I'm sure if they have some grants. They have some grants on Flow?
I'm not sure.
But actually they have, because there was like a friend of ours that built something of Flow in Taipei, I think so, last year. And now he's always a scholar for Flow EVM. So he's working with them, going through hackathons with them. He won a grant to keep going his projects. And so it's like very easy to access this kind of funding after an hackathon. Also, you can access to online hackathons. There is like this one that is hosted by Mantle. I will send you all the links in the chat, in the Telegram chat, of course. So, yes?
I won the first edition, first place.
Congrats.
Congrats. Congrats. And there is like the Cookathon, that is this Mantle. Mantle is a layer 2. So you just have to build, like, there is every month a cohort with 15k of prizes, and of course if you win you can ask for grants and things like that. So they like to try to give you a follow-up session to all this.
They have the flashlight
lightning grants.
Lightning grants.
Now they have now these lightning grants that maybe you can ask. It's like
10K.
Up to maybe not 20. Okay, 10, 20k, whatever. And
money, huh?
it's like lightning grants because why lightning? Because maybe you ask that after like 1 week or some hours you get an answer. So you get a regression or whatever, and you are able to keep following the your building on Mantle in this case. But there is also like the proof of ships with Celo. That is another one, layer 2. But if you go on all these in all these protocols chains, they have some grants and some programs that keep you like onboarded inside Web3 and also give you funding. But of course, there are also this one, ENS, that in particular ENS DAO, that is also supporter of this initiative. You can see we asked for a large grant, and we are the only one that got accepted at the moment. And but on this one is public good grants. What does it mean, public good? Is like that you have to you want to build something that is for the public, and it should be free for everyone, because of course it's a public good, like this campus. And you can ask a grant for things like that, like you want to build a protocol that maybe for carbon credits, things like that, and you can ask a small amount of up to 2 ETH, that is around 5k,
or a large grant up to 50K in USDC. And it's very easy to apply, actually. You just have to fill up this title, description, planned milestones, and how many ETH you want, until 2. So it's pretty easy. It's like 50 minutes to apply, and they will give you like an answer in 1 or 2 weeks. Of course, if you don't want to rely on bounties from the hackathons, if you don't want to rely on grants, maybe you want a more long-term job, but actually you have to know that in Web3 there are a lot of layoffs. But just Google for a Web3 job. There are a lot of aggregators that help you to find a good job for you. There are a lot of jobs for software developers, actually, many with good salaries. But the thing that I suggest you is like to go directly on the page of the protocols. Like this is Arbitrum, is one of the major layer 2 on the ecosystem. And if you go down, as all the other websites, there will be the career part, and you can see all the career that they have for software developers, or also other kind of careers like a community manager, chief of staff, these kind of things. And so my advice is not only to send like a lot of resume all around, but to maybe focus on some interesting protocols, so layer 2 or chain or whatever that you want to interact with. Maybe you know them in an hackathon with some networking in an event, then you deep dive maybe with a grant or something like that, and then you can access also directly to the job. This is how to approach for the first time to a job. Of course, if you are like an experienced developer, if you're an experienced hacker, or if you have done already some jobs in Web3, it will be very, very easier to access to other kind of careers. So yeah, that's pretty much it. And so you can follow up with the lesson. And I will give you these links in the Telegram chat. And if you have any question, just
All right. Well, okay. So let's talk about something we haven't spoke earlier. Very quickly. In Ethereum, we have 2 different things that are used mainly as value. One of those are this ERC20, or maybe like the other kind of tokens, in general tokens. But the main one is the native currency, which is ETHs. So, which is the same. It is the same kind of currency that you use when you pay for gas. So they have the cost of the execution of some function is calculated in gas, which is then converted in how much ethers do I need to pay to the network to execute a function based on the opcodes that are used on the low level. And we have a couple different methods to use ethers. And generally speaking, they are just used differently. So let's see how do they work. Like, for example, let's say that I want to let's change these mint functions. Let's say that we exchange some ethers in exchange for some ERC20 token. So rather than doing this pointless stuff that we made, we can actually make this contract able to accept ethers. To do so, it's very important that you remember that if you want to interact with a contract and send native currency to it, you need to implement this receive function, which is external. And there is another modifier that we haven't spoke earlier about, which is payable. And what is payable? Not found unit. Oops. The fuck?
It's an A.
Huh?
It's payable with an A.
I forgot the okay. Thank you. But yeah, it's abstract because of whatever. The fuck. Sorry, guys.
First external, then payable.
Yeah, but I don't think so. No. Oh yeah, I guess. What? Okay. Start virtual. I don't know why that's. I don't think that's the matter. No, it shouldn't. Sorry, I'm having actually a blackout. Let's ask. Let's quickly run this tutorial and ask an AI. I should know that, but I'm tired. That's why AI is sometimes very useful. It should be like that. I don't know what. Maybe I forgot about some to override some function that needs to. Yeah, let's try that way. Okay. External payable. I'm not sure, but yeah, maybe I did something random. Oh yeah, maybe because I forgot the parentheses. Yep. So it's important that you implement this receive function because if the contract doesn't have the receive function, if you're going to send ethers to this contract, it will revert because it doesn't have a way to handle incoming ethers. So if you ever happen to need to send the ethers to the contract, just remember that you need to implement either a receive function, but it may also be a fallback function. Maybe we can see more in depth what they do. So, especially maybe we can talk about fallback tomorrow. For now, it's not important. The term payable means that these functions that you mark with payable accept some other argument, basically, when you interact with it. They don't only accept some data, but they also accept something that is called just value into when you are calling function. What does it mean? It means that if we want to make this payable, for example, we can send some meters to it, and we can make use of this information by accessing this object that we can use in Solidity, which is message. So we can earlier we have a message sender to retrieve who is the entity who is calling this function, but we also have, for example, message value, which is how much ethers this function received. So, for example, we can, for example, say mint rather than using the hard-coded value that I used earlier. We can say that we exchange 1-to-1, so we can mint to the user the same amount of ethers that we send to the function. So if we deploy now this function, we will see that it is different now. It is like red. This means that in the remix, just in remix, you see it red because it means that it can accept value. In remix, when you are testing stuff, you can use some of this is the ethers that you have, quite a lot ether, and you can use this ether in here. So like, for example, if I send 1,000 ether, you can just call these functions, and as you can see now, the balance in ether of the contract just increased, and we should have like the token that we just minted, basically. So we can use this thing, and let's say that we want to forward this payment to some other contract. We can let's create like very quickly address in Gallo. Okay. Public order contract equal let's say it's not really another contract, but it's okay. You can also declare stuff like that, of course. You can hard code stuff if you don't want to, if you are like going fast and don't want to like input values in construction every time. So you can just do that. Like the method to send ethers is of course different from ERC20, and we usually do that way. We first declare the address we want to interact with. So in this example, we have like contract. It can be an external owned account, or it can be a contract. It's just that way. And we can use the function call, which takes two factors basically. In the curly braces, we can write value, message value, for example. So how much we want to send as value, exactly what the user input in this function, and then we can also write data in it. But what is function call user? Okay, it should be empty data like that. Okay. So if this was, for example, a contract, we can attach data to the call. But right now, what this is actually doing is just forwarding what the message value that we input into this function and send it to another contract. And we usually want to validate that when we do a transfer to another contract, we want to validate that the contract was successful. So we can write like boolean success, and this we can just write a comma that will be like bytes data, but we can just use just the success return. So this actual call by default returns a boolean to signal that the transfer was successful. So we may do operation because maybe we don't know, but the contract we are interacting with doesn't have a receiver, for example, and we are sending to a contract that doesn't have a way to handle these ethers. So we can make sure the call has been made successfully. So these are pretty much the two things that you use when you want to transfer value across contracts: native ethers and tokens in general, ERC20 or 721 and whatever. So we spoke about this, but we haven't spoke about errors and requirements. Let's do that now, because in the next line, what I will do if I were to code this will be checking if this contract call was actually successful or not. And we have two different ways in Solidity to write to like have a condition that may revert the contract. One is require, so we can write like require success, and so success to mean like it's equal true. We can either write that way or just success. So if this condition is true, okay, otherwise it will revert, and when it revert, you can attach a message to figure out when so the user, if the user gets a revert, he will be able to read what happened, basically, just for your clarity. So we can either write that way, which is the most obvious, maybe the most readable, but in terms of optimization of your code, you can also error transfer failed. You can also declare this error, and you can make a condition like more rather than requiring, you can write a simple if statement. If it's not success, you can revert. Revert is generally an escape. So if you call revert, the function reverts, basically. You can also have like an empty one. It doesn't necessarily need to be with the transfer. We could have a function that simply just revert. It doesn't make any sense, but you can do that way. If you write revert, after it you write the error. When this function will revert, you will be reading the name of the error, basically. And you can also like input some argument into the error. So you have like uint let's say like address to and you may want to write here, for example, other contract. So you can debug stuff if you know that it would emit this error with the transfer fail errored with the address that you used in this function. You can do that way in these two ways. It's up to you. I generally prefer error because gas-wise they are more efficient and more easy to like read, in my opinion. But require is just as fine, especially for the hackathon. Don't care about like gas efficiency. We as judges, we all know that the time is very, very low, and we are like very forgiving, at least me. So we have error, but we also have something different, which is similar to error, which is the event. Because when so what is an event in first place? Like we can write event like that and give a name like means successful, and we can write arguments into the event in here, like for example address receiver, uint amount, and whatever. It's up to you. And you also can have like indexed term in here that what is an event in first place. If now I emit this event by writing emit means successful, whenever I'm going to call this function, this event will be, you will be able to find this event into the logs of the transaction. So when you do a transaction, for example, let's make one just like to make it more clear. Let's say that this contract now. He asked me to just confirm. And I should be able to, let's say we want to send like a very small amount of ethers in here. If we now send this transaction, have you seen Block Explorers yesterday? Okay, fine. So if we now open the transaction in here, we can see a few things, like, for example, all the things, the transaction hash, who called this function to which contract. Here you can see the value that we used in ethers, in native ethers. But more importantly, we can go into the logs, and it's not working well. Okay, let me just try to change base scan, which is the transaction detail. Sepolia base scan. I don't know why it's not showing the logs right now, but okay. We can see that we have this with this event that we just created, and it's really easy to read. And of course, things are interpreted in hexadecimal way. So this is 100 in hexadecimal value. I don't know if you can convert to more readable one. No? Okay. And why would you do emit an event? Is mostly for the cost, because in Ethereum there are different storage. There are different way you can have data on your contract. One is the storage, which is the most expensive because you need to write stuff in the contract, and it will be persistent. And it generally is the most expensive way to store that, to use data, to access or to write storage. So in many cases, when you want to optimize your application, you can make use of event. The event is not data that you can access from the contract. So for now, for example, this event that I emitted is not something that I can retrieve from my contract. Is the one of the cheapest way to store data. Yeah.
And then store the metadata of the
exactly. Rather than storing this into the contract, you still can always retrieve that because it's written into the blockchain, but you can find the event in here. This is particularly useful with there are couples project like the graph, which is basically an indexer. It scans for like you write your own logic to make your endpoint basically, and I don't know why it's not because it's a little bit boring because he asked for signatures and maybe for me to log in, but for example, in here I made a few days ago I made a graph. Okay,
you leave it to Davide.
The user experience for this is a little bit, but whatever. Like, I'm not going to. I don't remember what is the mail I have on this account, but you basically write your own logic, and there is like this off-chain program that is going to read all the events that are emitted. So you stack up some data, and then you have like GraphQL to basically it's like having a sort of database to easily index data. And in some cases this may be very useful because Solidity is not like you can do everything in Solidity. Everything has a cost. Many things are not doable. For example, if you want to, like, let's say that I want to store users in my application, for example, and let's say that for some reason I want to have like an array of users, and this array gets very big. At that point, you want to make for cycle, for example, and every time you run a cycle, it has a gas cost, and so you can easily get to a point in which you have, like, let's say 10K users, and you call the function that cycles over and over, and you eventually run out of gas. Yeah, you pay a lot, but you can also surpass the limit of how much gas it can be used in a block, so your contract breaks, basically. It is struck. So if you want to make some correlation about what the user are doing, for example, if it's like an order book or something related to like DeFi or whatever, you want to have your application like display all your past orders, all the current one. It is a lot of data, and you're not supposed to like read that every time from the chain. Maybe you can use event to make a relationship within data. So this data is persistent and very cheap. So that said, I think should be pretty much everything. We made the errors, the event, and what else? Sorry. Yep. Okay. So for the sake of the like, I think how much time do we have like right now?
40 minutes.
40 minutes. Okay. Since we are going to write some Solidity code tomorrow, we do an application like together. We go step by step, but I want you to have some end of on the code. We can like save some time for tomorrow maybe, and if you already have Rust in your environment, anyone has Rust? Okay. Foundry book. We can install. We should first install Rust, I guess. Okay. Okay. That's actually. I'm not sure about like Mac. How do you install Rust? Install Rust in Mac. I'm not sure about how you are supposed to install Rust on a Mac. Brew?
I did it.
Who did it?
Brew comments.
Okay. But I'm not supposed how they. I'm not sure how they are supposed to call that. Ask ChatGPT. install Rust, and once you have Rust, you should be installing Foundry. You can go to foundry.sh. I'm not sure. I think this may take a while. Like, you're done already?
No, it's doing now.
Ah, okay.
And basically, how it works, it's like folder.
Yeah, you pretty much like initialize a project and you start writing your Solidity code in it.
It's like Red Hat.
Yeah, exactly. But main difference is that is more like JavaScript oriented. Foundry is a little bit like it's faster, it's better for testing, and more importantly, it is Solidity based. So you write Solidity test directly, and it's a good way to like keep learning Solidity while figuring out why something is broken. It has a very good testing tools, and more importantly, it's very fast. But I think we will take a look at the stuff that it contains tomorrow. You mainly have this Forge module to test, build, compile the contracts, and deploy. Then you have Anvil, which is like a local chain. So rather than like using, let's say, the injected provider we saw earlier and sending your transaction with your wallet, you can create a local one, which is faster, and you can like play with it. You don't need like testnet token to deploy and try things, and cast, which is like a command line to call functions to contract directly. But yeah, we will see that more in depth tomorrow. As for now, just install it, so tomorrow we are ready to go. Yeah. Where is it? Yeah. I'm not sure how much does it take. Like, I made my first install like years ago. Is it going?
I'm about to.
No, ma già fai male con
So, or good? Okay. If it's maybe installing in the background, we can keep adding like notions about some more useful things that you may be using in Solidity. So we spoke about pretty much all the types, the data structures, event errors, and whatever. We see that in here in this function we leverage the message value in that case, and something very very useful that you may want to do is that receive is generally empty. It doesn't necessarily needs to have logic, but you can write logic in it, and the way it does it just depends on what is your use case. But keep in mind that you can write logic in this contract. For example, let's say that I want to sell to require some just few people to like send to this contract. We can make like a requirement on message sender. I don't know. It's different from or equals from. You can write logic in it, like to handle if you need to, and you can also add argument in there. So the data that you are sending here can be used as data in that logic. So we spoke about that, and we haven't spoke about like what is in it a block, like get time, for example, public users uint. Okay. And what we can do also in Solidity is to access some information that is available at runtime for a given block. Like, for example, a block does contain many stuff in it. For example, base fee is the cost of the gas, the block hash, chain ID. These are things that you not necessarily going to be using very niche, but maybe something that you can use to make some application is block.number and block.timestamp. Because if you want to trigger some like, for example, you have an escrow in that as like a lock period, you can leverage these functions to like make some logic to prevent like you to taking the money too early or whatever. So that is something that maybe tomorrow we are going to use for the sake if we are going to make an application with for crowdfunding. So keep in mind we can use that. Okay. All right. You are done with.
Next phase we will see also like oracles.
Yeah. We can even do that now, I guess, because we may use it tomorrow, and I'm pretty sure Chainlink is having like some track related to oracles. So just to make everyone is on track, oracles. The main thing about blockchain is that they are closed circuits, so they don't have native access to the data that is outside. So if you need to read data from external, from the real world, it's a little bit tricky. And generally, there are few companies that are running Oracle services. And what they do is to basically they have some contract that they have control over this contract, and they send verified data from the outside world into this contract that you can read from, and they generally push the prices. It's mostly for DeFi purposes. Like for example, Chainlink, the data feeds, I guess. Okay, Chainlink does provide these data feeds, and if you go into the documentation, price feed address. Okay, these are all the chains that they support. Let's say that we want to work on Base. They have addresses for each contract, and if we want to know what is the price of Bitcoin, they have a specific contract for this one. So if you want to make an application with that needs to use this data to make conversion and whatever, you can call this contract. Maybe tomorrow we will see more in depth how it's done. It's like very easy, like the contract interaction that we had with the ERC20 token. We just import an interface, we pass in the address of this contract, and we are just good to read the latest price. I guess Chainlink is very easy for that. I guess they have latest round data. I don't quite recall what was the get answer. Okay, I will look into more. I think it was this one. What did I click? BTC. Yeah, this one. Latest answer. The price of BTC is currently 108K. Okay, and generally speaking, there are many Oracle providers for this for the hackathon. I guess you better use Chainlink since they have a bounty for it. They have many more services, like you can automate things in your contract, or they have also like something to read external data from let's say from external APIs and whatever. But generally these are more complicated. Reading prices more reading price feeds is more straightforward. That's we. Okay. All right. Everything done with the Foundry yet? Okay. Okay. So we don't have that much time, but we can start. Maybe we can start writing some code for the application that we build tomorrow, because I'm quite early right now. Oops. Very bad. Everything clear for now? Any question in particular? Okay. Okay, let me close this one. Okay. Oops. So the thing that we need to do in order to initialize, what is it? To initialize, you can just scroll. I think they have a page somewhere for like bootstrapping, but yeah, it's just literally that simple. If you run initialize counter, it's just initialize a very simple project. It does really doesn't really do anything crazy. You can just create your own folder and run forge init counter, but you also can run forge init basically. So what it does is that it just initialize your project, and let's have more or less a look at what it does contains. So it contains your contracts. This is a really simple one in the source folder, but you also have like a folder for putting in your test contracts, and a folder in which you are supposed to write your own script. Scripts are very useful. You can use them to automate the deployment, which is something that is generally up to you for your convenience for the next days. I don't know what Mattia will be doing exactly, so it's pretty much up to you. If you feel comfortable to work more in Remix and deploy by hand and playing with the buttons, you can do that. You are not like stuck with Foundry. But so everything we will do in here will be portable on Remix. We can write a contract here, and for your simplicity, you can either write the script for deployment or just deploy by yourself with Remix. So we can start figuring out the first important things, which is the imports. Since we are going to leverage a lot of contracts from Open Zeppelin or other protocols like Chainlink for press fits, we want to install some library. In that case, we can forge install. I think it's Open Zeppelin contracts. I'm not sure. Yep. So it's actually pulling this from GitHub. It's going to get the repository under ETH Open Zeppelin, and is taking the Open Zeppelin contracts repository. Okay. Once it's done, you will be able to find the library that you install into the lib folder. And one thing that you want to do, because now you don't have like a way to import this. I mean, you could just import this by giving the path from to the library, but for a better user experience, Foundry has the remapping that I don't know why they don't put it ready every time, but you can write remappings.txt in here, and you can write at Open Zeppelin equals lib what's the name in here? Okay, Open Zeppelin contracts, I think, and
Sorry, to pull this repo, where you can find this repo?
You can just GitHub. You can search for Open Zeppelin.
Not the Open Zeppelin one, the project the scaffold that you are doing.
Sorry, because you weren't in the room, I guess. I just run Forge init.
Okay.
And so now we should be able to, to import. Okay, let's, for example, ERC 20 token. Okay, it doesn't like that because I think I fucked up with the. Sorry, let me just quickly look at one of my repos because I don't remember. I always forgot about the correct syntax. Let me just find a random project. Nope, not that one. Okay, so the correct syntax. All right, it should be Open Zeppelin contracts, I guess. And what was it? So, okay. Maybe I'm not sure about this. No, it doesn't like it. Sorry, guys, give me a second. I always forget this stuff. It always take me a few minutes to figure out. Doesn't find it because the comment is fine. Fix the yes. Maybe that way. Okay. So the correct syntax for this to be working is that we use that Open Zeppelin alias to access this folder basically. So we have like the ERC20 token in the library is under token ERC20 URC20 token in here. So we can just import that way without writing the whole stuff. Let me just close this one. Okay. If you want to take a look at how it's done, I can like enlarge that. Do you see the OS2? Okay. Everyone now I'm not sure we are going to use this one, but let me think about it. Yes, why not? Okay, so let's try to start writing some code for tomorrow. How much time do we have? Do we have like 20 minutes? Okay, it's not that much. What we can do? Okay.
Do you know how basically I can see that your simplified gets tolerated by text get tolerated by if it's a variable and so on, function and so on, and my one is plain text. So I need to install some extension for cursor.
No, sorry, I didn't get the question.
So basically, if I check my solve file,
I got my plain text with no colors and nothing.
Oh, okay. No, you don't have like linters or whatever. You can go into here,
Yeah.
and you should find like few.
No. I think that is specific for Solidity.
Yeah, you have to find the one from Solidity. You should be able to find this one if you write Solidity. This one from Juan Blanco is the most. I think it's the most used.
Okay. 2 million. Yeah.
Yeah, there are quite a lot. I think this is the most used by far, but there are many. Okay. Okay. Let's jump into our what are the basic commands that we can write. So tomorrow we will refresh this because if we are going to build a smart contract together, we are going to use these commands over and over. Mainly, the one that we are going to use the more is just forge build. So what it does exactly what we are doing in here when we save or we click in here to compile the contract. This tries to compile the contract. It compiles. It tells you what is the version that you are using and many other things. And by the way, you can configure this in this Foundry toml. You can like use your specific compiler version if you need one. You can add code optimization and a lot of things that are all well documented in the docs. This is one of the few projects that is really well documented. And so if you ever need like to figure out an error or whatever, you can go in the documentation, and it's pretty big, but they have pretty much everything for testing. And of course, if we are tomorrow, we are going to write a test. This, of course, will give some information about what is going bad. For example, this takes a string. If I put a number in here, the compiler is going to say what is the problem, is going to underline where the problem is and whatever. So and another one is Forge test. We will mostly use this tomorrow. Forge test will take oops, okay. For test is just a command that it basically goes into the test folder, tries to finds the test file that you have in it, and in here you can write all your logic. So let's write a very simple contract for tomorrow. Like let's like set up this contract for now. How do I turn down this? On this done. Ok. Che cazzo. Vabbè. So the first thing that we want to do is to call this crowdfunding. Okay. And what we want to do in this contract is to like have some basic like function. The first one like maybe is to create a campaign. So in the case that from the front end it will be clearer, but let's say that we have like many like a form in which you write. Do you know like how Kickstarter work more or less? Like the crowdfunding platform, you have something that you want to do. People send the money to you in order to realize your goals, basically. So let's say that we want to build an application that we will have like user functions. Function to create a campaign. Wow, AI is going to steal my job. A campaign. We may have yes, a function to withdraw from a campaign and whatever. So the first thing that we can do is like declaring what a campaign is. So we can also like code along, but maybe tomorrow we could you write the code and I go around to see, and then we do some checkpoint together. But for now, let's just have this like a Q&A. Like, let's say that campaign, it is an object. So what could this possibly have is that it has a creator, which is of course an address. Then we may have some information that we can use to distinguish each one. So we can have, yes, a title. Maybe we can have a description. Goal, I don't know about goal. Maybe we can have like, yeah, a target amount. So how much do we need to, like, how many money people need to put into the campaign so that the creator can take the money. Like we can do that if until the expiration the price isn't met, for example. We can do in order that the creator cannot take the money, and it's refunded to all the people that put the money into the campaign. So like this can be 200 goal, for example. And we can have like a deadline. Holy shit. Okay. Deadline will be just like why it keeps changing. Okay. Deadline will be like block.timestamp, no? And block.timestamp, actually, I didn't say what is it exactly, but it is Unix timestamp. You have an idea what is? Yeah, okay. Just to make it clear to others if you don't know, Unix timestamp. So basically, Unix timestamps is the time elapsed from 1917 till now in seconds. So,
In second or millisecond?
It depends. I think that JavaScript treats it in milliseconds. Solidity interprets in seconds. So, but for example, I think this one is in second. We can have. This is basically the big number that we are going to receive every time we go for that. Because of this, since this number is never going to be too much big, like if we look into like in 2000 year, if we expect Ethereum to be still there, we're still going to have a pretty much small number compared to the maximum amount you can have with a uint value. So this is a good chance to make some optimization about the storage cost. For example, now I'm not sure. I generally think people use uint32. Let's see how much. Oddio. Vediamo se. Let's see if AI knows that. Notation. Okay, it's not every notation, but as you can see, uint20 to 56 is very big one. Generally, I think that maybe 32 may be okay. Like it's not in 200 years, maybe it's in 100 years. But so if you believe maybe Ethereum is going to be, your contract is still working in 100 years, you can use like maybe 64. So that is maybe as I told you, like a good chance to make to show you before we going something we haven't spoke about, which is like type mismatch. So if we have let's say that now in here we want to use uint64, we need to know that when we are going to deal with functions, there might be cases in which like you are trying to input directly without casting the value uint64 into something that expects 256. In that case, we can simply, Solidity is very simple with that. If it stops maybe function cast 060 for 2. Okay. Await if in this function, for example, I want to return this explicitly like uint to uint 256, so we can just open the parentheses and cast in this way. It's very simple, and we can do that with pretty much every combination of. We can also do that from integer, like function cast e64 to okay, and of course what we need to do in this case is that we should make sure that we are using modulo of the value, because I think if we put a negative value in there, the casting won't be. Yep.
That is for setting up the deadline of the collecting funds for.
Yep.
Don't we usually use block time for that?
Yes. I said it earlier.
Oh.
Okay.
Sorry.
No, I was just showing like that we can add different types of, and we can use casting in a simple way. And of course, this we haven't spoke much about bytes as a type, but we can also have casting other values like uint as bytes. Like for example, in here I want to return this as bytes 32. We can simply do it that way, and it's very easy to cast values in Solidity if you need like to match exactly this signature of functions. Okay, so we can just delete this for now. So what else do we need? Yes, of course. I was trying to like do it myself, but the AI gives. Okay, unit 66 and amount raised. Then we can we can have. Yeah. Yep, exactly. What we can do, maybe in here we can have, for example, an enum. Did we spoke about enum earlier? I think not. Okay, enum is very easy. Like you have some more readable state, like active, completed, failed, for example, and these are 0. This will be represented by 1 and 2. It's just a way to like use a more compact way to express statuses. So we can have like campaign status, and if we want to set this, we will do like campaign status dot active, and it's really for clarity. Whatever we can do in here.
Others participants.
Okay, that is something that we may do, of course, but we don't want to like have something like that generally, because yeah, it's not the like it's not like you cannot do that, but you have to think about why am I putting an, let's say that this gets very big and you have like 10K contributors. Okay. You cannot cycle, and you
instead I'm happy where
yeah, you would also need to like figure out a way, okay, what is Marco index in that array? Where is him? Like you.
And instead, I'm asking where the address is the key.
Yeah, exactly. We do that way. Like we could write, for example, yeah, we can do that way, and like have. I don't know how to disable this stuff, guys. Sorry. We can have like a mapping in which we declare address contributor, and we can map this like a boolean to say yes, he contributed, but we can also like just store a number of how much he contributed. So if the contribution is 0, he didn't contribute. If he contributed, he has a number, of course. That's more like the null problem we were talking earlier, man. Okay. I mean, that's more like similar to the stuff you were asking earlier, like we can make more smart assumption to figure out if a value is null or not, or whatever. So, like for example, unit amount contributed public, and this will be contribution. Something that I haven't spoke about it, but it's really up to you guys. It's like Solidity is general, like camel case. So the standard, the people expect you to write functions like, for example, not functions but variables that way. So you start with it's camel case, I guess you know. And I personally like write an S before the variable if to distinguish like storage one. Many people do that way. You are not forced to, but be,
Can you repeat which one is best practice?
like for example for variables and stuff, camel case is the way to like just make make your code consistent because for readability or whatever. Like people is very can be very like non so la parola pignolo per
Toxic.
no. Okay, so we have a contribution, a contributor, an amount contributed, and what else do we need in here? I think it's pretty much all. Okay, so we can delete this. We don't need that. We can start like creating a function to initialize a campaign. So if you are let's say the user, you can create campaign, and the campaign that you are going to, of course this function is public, everyone is allowed to create a campaign, and so we don't need any identifier for it, and but we want to make some argument that we need to for initialize the struct. So of course the creator is already someone that we know because we can use message sender later, but maybe we can like write string memory title, string memory description, and a goal. So uint goal, uint 64 deadline. Yeah, okay. Let's call that expiration date. It's more clear. And we can go very far away. Generally speaking, people tend to format functions that way. It's more readable. Huh? Yeah, we can do that, but just yeah, we can do that. It's up to you. I was just but what else we need to okay. Good catch, by the way. Yes. Wint minimum amount to receive, and okay, this one is going to be deleted, and you see the point. So if anyone remembers that, now we can create the object, but we have different ways to do this struct. Earlier, if you remember, I wrote the name of the type of the struct, which is like now campaign, and I wrote that way campaign. Then I filled and whatever. But we can also like use directly the storage, so we can like write. Oh, we forgot. I forgot something. Che? Dobbiamo andare? Mannaggia. Yeah, we would have like a counter to figure out the counter, and then have a mapping for int a campaign ID. Oops. To the object campaign, but I guess we are running out of time, so we will complete this tomorrow. Campaigns. And okay, just to finish off, we could eventually like write that as campaigns at the index. Let's say for now just a number. Tomorrow we will do that better, and we can just create a campaign that way and fill in that way. This will go straight into the storage. So there is many. You can do that in whenever, however you prefer. Okay, I think we got to wrap up. Tomorrow we are going to do that together and figure out some